a step-by-step guide on how to set up a drip irrigation system. I did a ton of research and I want to provide all that information to you guys to help you guys get started.
So the first thing you should consider is measuring out your plot and drawing up a sketch. This is going to give you a better visual to know how much tubing and other components you may need. This can also save you some money by not overbuying on equipment. Now, I've already had my plot drawn up using Google Sheets, but you can use whatever works best for you. Now, your sketch should be as proportionate as possible to get the proper length of tubing. Each one of these squares in my diagram represents 1 square foot. This bed here is 3 feet in width and 6 feet in length. Now you can see the sketch on this diagram is proportionate to the actual size of the actual bed. And as I said before, 1 square equals 1 foot. Along with where your beds are or your growing space, you're going to want to also plot out where your water source is. Now that we have everything mapped out, let's talk about tubing.
It's totally tubular.
First and foremost, there is no standardization when it comes to drip irrigation. All irrigation companies have similar products that may be named similarly, however, they aren't interchangeable.
That sucks.
So do your research in regards to what company you want to do business with and stick with that company for your entire drip system. For me, I chose Drip Depot. Not a sponsor, but I definitely heard good things about this company and their products. For the first set of tubing, we're going to be talking about supply line tubing, also known as mainline tubing.
I'm gonna go drain the main vein. How about that?
This is tubing that's going to start at your water source and run water to your beds or grow area. Think of this tubing as your city's water line coming up to your house. Supply line tubing comes in 1/2 inch, 3/4 inch, and 1 inch diameter. Each of these sizes has a maximum run length and a maximum gallons per hour that can be supplied. If you have a medium-sized garden, 1/2 inch should be a good starting point. So now let's see if this 1/2 inch tubing will work for our setup. First, we can see that the max run length is 200 feet. That means we have to measure the total length of the tubing laid out in our garden, and the total needs to be 200 feet or shorter for the system to function properly. But since we have a diagram, we can easily sketch out how we want the supply line to run. So I'm measuring the shortest distance from my water source to my first bed, which works out to be around 14 feet. From there, I'm trying to figure out the shortest distance to run the line to each of the beds. This took me a few different iterations, but I landed on this layout. Now, there's no right or wrong way of doing this, but what I kept in mind during the process is thinking about the connection pieces that are available. There is an array of different connection fittings that can be used. However, the main ones are elbows and T's. These all come in various sizing that the tubing comes in, but remember, we are running our 1/2 inch main line, so they will need to specify 1/2 inch. But I'll talk more about the fittings later. So now that we see the two shapes we have to work with, you can see how the connection fittings played a role in my layout. So now all we have to do is add up the entire length of the main line tubing, which works out to be roughly 90 feet, but I'll round it up to an even 100 feet. And to add a little extra for any scaling errors, I'll add an additional 25 feet. So the length that I'll need is 125 feet of mainline tubing. That falls well below the max of 200 feet. So that checks off the first requirement. Now if our length was higher than 200 feet, then we would need to scale up to higher size tubing, which have longer max lengths. But since we're good on the length, it's time to check if the gallons per hour will be sufficient. And gallons per hour is exactly what it sounds like. It's the total gallons per hour that the tubing can supply. So to see if 200 gallons per hour is sufficient, we need to talk about another set of tubing called drip tape and drip line. Each of these takes water from the mainline tubing and distributes them directly to the plants. Think of them as your shower heads and sink faucets in your home that get water from your city's mainline. There are pros and cons to both, but I'm going to choose drip line, which is what we have here. This is 1/4 inch drip line that has these pre-drilled emitters every 6 inches. You can buy drip line with specific pre-drilled emitter distances like 4, 6, and 12 inches. Each can emit different gallons per hour. Or you can even get drip line that has no pre-drilled emitters, where you yourself install button drippers to the ends of the tube for a more targeted watering. These are mainly used for watering potted plants. Here are the specifications for my 1/4 inch drip line. We have the max length of 30 feet. Next, the drip line emits 1/2 gallon per hour every 6 inches. Going back to our diagram, I'm going to map out the drip lines that we will be laying directly in the beds. It's recommended that 1/4 inch drip line be spaced out every 12 inches. What I plan to do is add the same number of drip lines as the bed is wide. So a 2-foot wide bed will have 2 drip lines going straight down. A 3-foot wide bed will have 3 drip lines going down, and so on. Now you don't need to have straight lines. You can zigzag the drip line as you please, but just remember, each line should not exceed 30 feet. And now that that's all mapped out, it's time for more math.
Alright, I'll do the math, but I'm not gonna meet with any fucking therapist.
I'm going to be focusing on this bed here. This is a 2-foot by 6-foot bed. The drip line is going to expand the entire length of the bed, which means the drip lines will be 6 feet. And I plan to run 2 lines for this bed. Because the drip line emits half a gallon per hour at 6-inch intervals, that means every 1 foot will emit 1 gallon per hour. That's 6-inch plus 6-inch equals 1 foot, and half a gallon plus half a gallon equals 1 gallon. So all I have to do is add up the squares per each of my bed, since each square represents 1 foot, to get the total amount of gallons per hour. So the output for this bed is 12 gallons per hour. So the total works out to 155 gallons per hour, which is below the maximum gallons per hour that can be supplied by our 1/2-inch mainline tubing, which checks off the last box.
Check, please.
Now that we know 1/2-inch mainline tubing meets our requirements, can our faucet meet the demand? Well, to check, we need to measure the flow rate of our faucet, which will show how much water can flow out of it over a period of time. To do this, you will need a bucket of any size and a timer. I'm using a 5-gallon bucket, then timing how long it takes to fill using the faucet head that will be used for our drip system. After that, I plug in the numbers in a flow rate calculator. This one is from Drip Depot's website, which I'll link in the description. Now we have the max gallons per hour the faucet can supply, which is 361.74. That means the flow rate of 361.74 can supply the max needed gallons per hour of our entire drip line, so that checks off the last requirement. If the flow rate of your water source was lower than the total gallons per hour your garden needed, then you would have to do what's called zoning, which is dividing your main line into 2 separate tubings. Each of these separate tubings or zones will lower your gallons per hour by dividing by 2, if you decide to only use 2 zones. Each zone will need to run one at a time, as running both zones at once is the same as having 1 mainline tubing. Now that we know our 1/2-inch mainline tubing can supply the proper length and gallons per hour needed, and our water source can flow at the rate the garden requires, it's now time to head outside to piece the irrigation system together.
The time has come.
So the first thing we need to talk about is the head assembly. This is a portion of the system directly attached to the faucet. The head assembly can protect and maintain the life of your drip system. Now here I have a 2-zone Wi-Fi irrigation water timer from Rainpoint. Now this is a smart timer, which means that it connects to the Wi-Fi, and I'm able to actually set a watering schedule, measure the water usage, and start and stop my irrigation system all through my phone or other devices. Now a timer isn't necessary for a head assembly, but it's definitely going to make my life much easier. After the timer, you're going to need a backflow preventer. Now this is going to prevent water from actually going back into the city's mainline or your water source, to prevent anything from contaminating your water and or your neighbor's water. After the backflow preventer comes the filter. Now this filter is meant to filter out any large debris or sediments that might come from the faucet, so this can prevent your drip lines from clogging. Here you can see me realizing that the entire head assembly isn't going to fit, so I'm going to have to do some readjustments to my spigot. After the filter comes the pressure regulator. Now this one here is 25 psi, but anything between 15 and 25 should work. A pressure regulator is used to regulate the pressure in order to prevent the tubing from any damage. And lastly is a hose thread adapter. This is what's going to attach the start of your mainline tubing. This is what the head assembly looks like. And now it's time to run the drip tape. When running your tubing, I highly suggest using gloves. If not, your hands are going to take a toll.
I better use my strong hand.
Also, measuring out each portion of tubing to cut and then cutting that specific length, but giving yourself maybe 2 to 3 inches extra. That way you don't waste long stretches of tubing that ends up being too short. You can see here that I use a T-fitting where the water will flow in this direction from my faucet and up my bed. And at minimum, I would purchase 1 T-fitting per raised bed. And at the top of the tubing, I put an elbow, which is going to extend the drip line across the width of my bed. So we got the end caps here that you can screw on and off. I can't do it with one hand, but this piece comes off just to clear the lines out if necessary. We have a clamp to hold down the tubing, another clamp, and here is an on and off valve, Just in case I don't need this bed to be watered, I could shut it off while letting the water flow through the rest of the system and the rest of the tubing. Now basically what's left to finish off in this bed, the puncture holes and then add the drip lines across the bed. We're going to start to install the drip line tubing. So again, here's the tubing with the 6-inch emitters. Now all the couplings for the 1/2 inch are basically the same for the 1/4 inch. So we have the elbows here for the 1/4 inch line, same as the drip line, obviously smaller. We have the T's, we have the clamps. These are the barbs. These are actually plug into the main line. So this is like the little converter or whatnot. So we would use the punch hole in the main line, punch a hole, throw on one of these barbs, and then run the tubing on the other end. And then here are the drip emitters. These are going to be for the pots at the end of the main line. Here are basically the end caps. They're called goof plugs. Not sure why they call them goof plugs, but basically they're the end caps for the 1/4 inch drip line. And here are the stakes for the actual little drip emitters here. So you can see it's basically the same connectors and everything for the 1/2 inch. It's just in the smaller 1/4 inch size.
Size matters not.
Now this bed is 2 feet wide, so I'm going to be installing 2 drip lines. I'm using the measuring tape to get an even spacing of those lines, then using the punch tool to make the holes and inserting the barbs. Now all that's left to do is insert the drip lines to the barbs and run them through the bed, and using the goof plugs to cap off the lines. One optional installation process is trenching. I dug down 3 to 4 inches to bury the main line. This will keep the line from corroding faster than it would be if it was exposed to the sun. It is much more time consuming, but I think it keeps the garden tidy and can make your system last longer. Before running your entire system, you want to have all the valves on your beds closed. Then you want to go to each of the beds one at a time, open up the valves, and run your system to clear the lines of any dirt or debris. This will prevent your drip lines from clogging. Alright guys, so I ran all the drip line, all the valves are open, so it's time for a test. Here are the lines filling. Sounds like things are dripping. Got action. Oh, looks like we got a leak there. We gotta fix this. It is not holding on well. But yeah, I'm gonna stop it now. And it's fixed. So basically I had to replace this whole main line here. I think I just kind of stabbed it a little weirdly. It didn't go straight in the first time. But now, no leaks. Definitely check for any wet spots where water shouldn't be coming out of, especially at your end caps along with your T and elbow fittings. You definitely want to fix all the leaks before you bury your main line.
And that concludes the video. I hope this video actually helped you. I'm trying to put a lot of information in that I wish that I had, that I figured out myself. If you want to help with the channel, give a thumbs up if you did like the video. And don't forget to subscribe using the on-screen icon right below me. And if you want to check out any more of my other videos, you can click on any of the thumbnails to the side of me. But as always, you won't get a harvest if you don't sow seeds.